layers of data delivery. So we're looking at different Ethernet and wireless LAN uh, suffering from considerable unreliability. But Mac in general was designed to address that particular issue within wireless LAN. So issues of unreliability at the Ethernet and wireless LAN level uh, were well addressed within the reliable data delivery systems of the wireless LANs. In a way, the Mac layer's job is to make sure that there's reliability. Since generally Ethernet and wireless LAN suffers considerable unreliability, so there has to be a way to make sure their data that's been transmitted or delivered through that medium or that particular layer is it's quite reliable, basically. The other functionality was access control, where you have distributed access and then centralized access, designed to basically uh, play a key role in handling the distribution of the various nodes or stations that a particular given MAC medium or medium access control supports. The other one happens to be security, which is obviously trying to fulfill the need for accurate transmission as well as hacking and eavesdropping within wireless mediums. So it's the job of the media access control or the MAC layer to to address some of these key essential functionalities. So we can consider, the MAC layer of the wireless LAN uh, efficient or effective or reliable. And in terms of data reliability, uh, usually the MAC layer, uh, some of the challenges that goes with it are noises, interference, and other propagation effects, which results in loss of frames. And even with error correction codes, frames may not be successfully transmitted or received at either ends. Uh, so ideally, MAC needs to come into play, um, or it was designed and structured to make sure reliability of data delivery is guaranteed. The 803, sorry, the 802.3.11 also includes some frame exchange protocols, which allows frames from stations uh, to return acknowledgement. So at least when information is transmitted, uh, the transmitting node or station uh, can know the status of the message being transmitted through that acknowledgement. Okay, so this exchange of frames uh, is treated at the atomic unit where there are no interferences or interruption by any other station, especially during the transmission of those frames and the acknowledgement receptions. For further enhancement and reliability, four key frame exchange had to be used. We are basically looking at how efficient the media access control is in terms of delivering reliable data. Okay, so keep that in mind. Oh, great. So the all over here. So to further enhance reliability, we do have four frame exchange made, and one happens to be to address, just basically we're trying to make sure that there's that reliability. Four main exchange implementation were put in place. The first one happens to be source issues a request to send um, to destination. So when it comes to two devices, one's transmit or exchange a particular message, The source will basically issue a request to send or your RTS destination, and a destination responds with what you call a clear to send or a CTS. Then, after receiving that CTS, the source can transmit the data. And generally, your request to send and clear to send notify each station that the transmission is underway. So they refrain from what? Transmission, not to avoid any kind of collision. So when two devices are transmitting or giving particular wireless LAN, it's some of these key exchange implementation uh, that helps to make sure the information is delivered reliably. And obviously, destination has to acknowledge after the messages, after the frame has been received at the destination end. The general purpose of your RTS and CTS is to avoid collision, basically, or the collision time happens to be shortened because collision only occurs on the request to send frames, which is very short compared to your data frame itself. So generally, if the purpose of your RTS or CTS is to avoid collision by shortening uh, that request to send frame in relation to the data that's been transmitted. Okay, so that's the key purpose of your request to send and your collect to send. So after reliability, it obviously has to be security, and that's where we look at authentications, de-authentication, and privacy. Okay, so key security measures, authentication, yeah, exactly. So you have, of course, de-authentication as well, and then privacy standards are quite important over here. One standard is the web or the wired equivalent privacy for Wi-Fi systems. And then you do have your Wi-Fi protection access or your WPAs, which are designed uh, to robustly handle various Wi-Fi transmission at the security and privacy level of a given transmission on the wireless LAN. Obviously, we do understand what authentication is, where users authenticate, either via some kind of logins or keys, IDs or whatever, tags or whatever. Okay, and then obviously de-authentication. Okay, so I did look at the physical layer already earlier on. In summary, you have your frame control, duration, connection IDs, addresses are key part of the frame as well. Your MAC address, sequence control, the frame body itself. So at least we know the physical components. So generally here we're looking at uh, the frame format basically of a Mac. And frame control is one of them. It's one of the first ones. The duration or connection IDs or tags for mostly authentication, and addresses for actually identifying source and destination. Sequence control to manage how frames are organized uh, while in transit en route to a particular destination. So when they get to that defined destination, they can be reorganized in the right order for a meaningful delivery of that particular message. And then finally, you do have your frame by which the data itself that's been carried. Collision is one key challenge that you face within wireless LANs. That's one of the reasons why request to send and clear to send was negotiated as part of the or as one of the key um, frame exchange that was agreed upon within reliability of the delivery. So here we do have A and B, which is that within various propagating cells, okay, or A, B, C that within various propagating cells. Um, in this case, you have A and B can actually hear each other. B and C can hear each other, but A and C cannot hear each other because obviously they are on either side of a given transmission. So when A is sending data to B, C cannot sense, that activity going on. Kind of like the way it is for Ethernet, especially when you're using either the letter lower or a lower by itself without any uh, carrier sense multiple access with collision detection added to it. So in general, I would probably say that uh, collision detection or carrier sense multiple access slash collision detection and collision avoidance are a key role to address wireless transmission collision challenges. So within this scenario, if A is sending data to B and C cannot see the activity and hence C also tries to send particular information, then collision happen. So the best way is to consider the effect of what? Request to send and what? Collect to send. The request to send alerts all stations within range of source, that is A, that exchange and away. So clear to send alerts of all stations within a range of that particular destination needs to be aware, needs to be notified, so at least they don't also try to transmit. Other solutions, some of the challenges that media access control faces, besides collision, is to implement two sub layers under the MAC layer itself or the media access control layer itself. You'd have under those two sub layers, you'd have a lower layer that is designed as a distributed coordinated function. And the use of that is to address contention algorithms, or say to address contention based on contention algorithms that provide access to all traffic. And then, and then you have your higher sub layer, which happens to be your point coordination function, and generally uses a central algorithm to avoid, collision issues within Mac. It's contention free, as well as implementation on top of what your distributed coordination function. Remarks here is you have to keep in mind that in terms of remarks, the point coordination function has not been properly implemented in today's 802.11 products, which means your DCF or your distributed coordination function is more or less the most widely used control measure for Mac media for Mac or Mac media access control. Okay, so here we talk about how other distribution coordination function, which is your DCF, uses carrier sense multiple access with collision avoidance to to address collision issues that you might have. So that sublayer uses the characteristics multiple access with collision avoidance protocol. And here works with a scenario of how this DCF handles that particular to avoid any kind of collision. So a station with a frame to transmit senses the medium first. If the medium is idle, it waits to see if the medium remains idle for some time, which is equal to the delay called interframe space, or your IFS. If so, the station may transmit immediately. Now, if the medium is busy, then the station defers transmission and continues to monitor, then the medium becomes idle. Once the transmission is over, the station delays another interface space, and then if the medium remains idle for this period, then the station backs off a random amount of time. It could be a P minus N minus P or whatever it is. And then again senses the medium first, or to make sure the medium is still idle. When a station realizes the medium is still idle, it's not idle anymore, then it may transmit. During the back off time, if the medium becomes busy, the back off timer is halted. It's the back off timer that's halted and resume when the medium becomes more idle. Now, if the transmission is unsuccessful, which is determined by an absence of acknowledgement, obviously, then it is assumed that a collision had occurred. Obviously, if you do not get an acknowledgement, you can just, pre-assume that you had a collision along the transmission. Now, to ensure that backoff maintains stability, binary exponential backoff. When we had backoff uh, uh, and other kinds of backoff within the Ethernet. So within this one, we do have a binary exponential backoff to address, to keep backoff sustained or stable. Now, question: why not use collision detection? Now, collision detection is not practical for most wireless network. The dynamic range of wireless signal is quite large, and the transmission station cannot distinguish between weak signals from noisy channels or noisy transmission. So in that sense, a collision avoidance is a better option than collision detection. So in the next slide, we'll look at the MaxFrame itself, the format, just like Ethernet format. MaxFrame also has its own format. Control frames, the duration and connection ID, sequence control. The job of the frame control is to indicate a type of frame for control and management of data that comes through. Control frames usually handles the request to send and request to send, as well as receive acknowledgement. And then the management frame handles more or less your billings, true stations, and access points, and frequency location as well. So here we talk about the various fields that we have. Duration, connection ID, used as duration field to indicate a time in microseconds. The channel through which it's been allocated or that has been allocated for a successful transmission of a MAC frame. In some control frames, though, they contains associations or connection identifiers that are used for a particular purpose. So hence the duration and connection ID. Addresses, quite huge. The address and meaning of the 48-bit address fields depends on the context itself, which is uh, which is the given uh, type of address that we're using for that MAC frame. But generally, they're 48 bits, which will house source address, destination address, transmitter address, receiver address, etc. Now, sequence control has got 4 bit fragment numbers, which happens to be subfields used for fragmentation and reassembling. So this is where the reassembling is done. 12-bit sequence number used to number frames between given transmitters and receivers. A frame body is obviously where you do have your MSDU or your fragments of a given MSDU. Frame check sequence contains about 32 bits cyclic, which handles your cyclic redundancy check. So in general, to summarize all of this, a wireless LAN uh, in its sense is supported over a wired or the airwave through a wired backbone generally, and obviously sets a number of applications, and with application comes with obviously configurations as well as standards before you can address and meet your requirement needs. And also on top of that, you also have to look at how control mechanisms can be put in place to address issues that relate to um, collisions. And we did also look at some of the problems in the collision and how it was addressed using carrier sense multiple access, collision avoidance, as well as your request to send and clear to send. So that just happens to be your overall or your overview summary of your wireless um, LAN implementation or topic. So, anyways, guys, read chapter 17 um, from 1 to 5. It pretty much has all of the reading materials and other reference materials from for this particular topic.